Hello, this is lesson 4.4, equation of a linear relation. So up to this point, we've been looking at linear relations that are in all different kinds of representations. We've looked at them in graphical form, so I'm just going to highlight some words on this page. I'm going to read the words eventually, but I'm going to highlight some words. We've looked at them in graphical form, and when they're graphed, they form a straight line. We've looked at them in table of value form. And when they're in a table of values, the first differences in the dependent variable, so that's the variable on the right-hand side of the table, are going to be equal as long as the change in the independent variable, that's on the left-hand side, so dependent variables on the right-hand side of the table of values, and the independent variable is on the left-hand side of the table of values. As long as that's constant as well, your first differences are going to be equal. And we've also looked at these in equation form, and we looked at linear relations and what their equations look like. And a generic way of describing the equation form is y equals mx plus b. And each of those, or y equals b plus mx. We talked about before that you can put the starting value first and then put the constant rate of change in an equation, or you can put the constant rate of change first or put the starting value. And so down here, I describe what each of those letters in that equation mean. So y is your dependent variable, so maybe that's like the cost. And so the cost depends on how many people. So we might have something like cost equals, so there's y would be the cost, that's the dependent variable, equals m is the croc. So m is that constant rate of change. So let's say it's like $25 a person. So that could be $25 times the number of people who show up. So x, that's your independent variable, so that would be how many people. Cost depends on how many people. So cost is your dependent variable. How many people there are, that's your independent variable. And then you have to add some kind of starting value. Now, sometimes that starting value is 0. So like, let's say you have a job and you work 3 hours and you make $15 an hour. Well, you're going to make $45. You don't make any more, any less. So there is no extra little starting value there. Though sometimes you might have a job where you have a base pay. Maybe your base pay is going to be $300. And then they're going to pay you, say you're working in sales. They might pay you $200 per car that you sell or something like that. So you get a base pay of $300. That's your starting pay. And then for every car you sell, you get an extra $200. So B is the starting value. So let's say we're renting a hall and it costs $200 to rent the hall. And then it's $25 per person for the meal. So this would be an example of a linear equation or equation to represent that linear situation. Or we could write that as C equals 200 plus 25n. Either way is fine. But these are linear relationships, and these are different, what we call representations. So representations. So different representations of linear relations. So you've got graphs, you've got table of values, you've got equations, and you also have word problems. And so today what I want to do is take a look at how do you go from the words in a word problem to the equation. We've looked at how to go from the graph to the equation. We've looked at how to go from a table of values to an equation. We've gone from a table of values to a graph to an equation. We've done all sorts of things. We've gone from an equation to a table of values to a graph. And what we want to be able to do is go back and forth and be able to do any representation. When I give you one of those representations, you can figure out what all the rest of them are going to look like. Okay? So that's what today is about. It's about trying to figure out what the equation is going to look like based on the words in the word problem. And sometimes that it's very easy, it's very straightforward what the equation is going to look like, and other times it's not so straightforward. Okay, so that's the introduction for this particular lesson, and I'm going to stop this first video there and get started in a second on the second video.